Good day, everyone. Good day, students. Hope you're enjoying this time in math where we're talking about expressions, doing some work on different kinds of expressions, not different kinds of facial expressions, but different kinds of mathematical expressions. So it's all math. It's all working with numbers and letters. Get me out of the way here so these facial expressions don't get in the way of our mathematical expressions. Here we go. We've talked a little bit about expressions such as, say, 5a plus 6f minus 3. And then we've even said, hey, if a is 5 and f is 6, we can put those numbers in place of the letter. If they're equal, we can just place them there. And then we're at 5 times 5 plus 6 times the 6 goes in there. Oh, look at that. Look what I'm doing is I'm just making it up as I go. And then you can just solve that, type in your calculator, or you know that 25 plus 36 minus 3 is, I have no idea, 50, 61 minus 3, 58. I'm kind of wasting time right now. I'm just kind of reviewing what these mathematical expressions are. Let's get to today. In a mathematical expression, 6.2a minus 5.1j plus, let's do 1/2 q. In a mathematical expression, each of these items right here that are separated by plus and minus, they're on their own. They're called terms. These are terms of the mathematical expression. So for example, this one has 3 terms in it. We've got this term with an a on it, this term with a j, and this one with 1/2 q. Let's say what if there was another term there, plus 4? Well, then there'd be 4. Or to make it easier, so I'm not confusing you, what if 8? Just plus 8. Well, then there's 4 terms. Why 4 terms? Because there's this one and this one and this one and this one right here. So mathematical expressions. If I have 5 plus 6 minus 9 plus 2 plus 3a. This mathematical expression has 5 terms in it. Now, yes, well, wait a second. We can just, we could add and subtract those. We're not doing that yet. Just so you're aware that there's the word terms means that's how many, that's the items that are being added and subtracted together in a mathematical expression. What if you have terms that look like this? 1/2 j or negative 2/5 x or 3 and 1/2 m. What about terms like that where there's these fractions with a variable? You might sometimes see them written like this: 1j over 2. And if, like you hear me say, if we're being lazy with the 1, just plain old j over 2. These mean the same thing. The j, the variable, can be off to the side, or it can be up in the numerator. It's the same thing. And I could show you how. I could show you why that is. Maybe I will here in a second. But this one right here, this negative 2/5 x, that's the same thing as negative 2x over the 5. And yes, that negative, you can put the negative down here. It's the same thing as negative 2x over 5. We've talked about that negative sign and how it's equivalent no matter where you put it. But this x can go in the numerator as well. Just so you know, these mean the same thing. So on this one, let's see, 3.5, that's really 7/2. So that could be 7/2 m. And the m could go on top there. The reason that is, like this 1/2 j, that's 1/2 times j over 1. And then if you multiply straight across, you have 1j over 2 times 1. You're really just multiplying, one way to look at it, multiplying 2 fractions together. But just so when you see these terms, a variable can go on the top or it can go off to the side. Either way, it means the same thing. So what do you think it means when I say like terms? Are they terms that you like? Are they terms that like each other? Ooh, let's use that. Negative 5a plus 6 minus 3 plus 2a minus 1. Let's say that they're like terms because they are alike. They look alike. They have the same characteristic. And on this one, it's either a number, the numbers you can put together. And the other terms are if the variable is the same. If the variable is the same, you can put them together. So if you do that, this operation, this negative goes on the 5. We're adding the 6. So the plus goes with the 6. This minus is with the 3. The plus is with the 2a, and the minus with 1. So these ones are like terms right there. And then the 6 and then minus 3 and the minus 1 are like terms. That's just what it means. If I've got 1b plus 2c minus 3b, I can make it a b, plus 16a minus 4 plus 3b. Which of those can you put together? Not put together. Which of those are like terms? We'll talk about putting them together later, but which of those are like terms? Well, I've got this 1b. Is there anything else that goes with that? Yes, this b, this minus 3b, is like that because they are talking about the same variable. And this b over here, those are the same. Well, we've got 2c. Does that go with any of these? Well, no, that's not a c. That's not a c. So these don't go together. They're not like terms. I guess I could say they don't like each other, but I don't like how that sounds. I don't like how that comes across. Let's all like everybody. Numbers maybe can be choosy, but let's not. Let's us be working together. So like terms are where the variables are the same, or constants right here. These constants, you've been working with these since kindergarten, or they're the same. Okay? So let's say I've got a term. Let's say I've got, let's go with maybe a 13W. Well, I'm going to do it this way. See if this is a little easier to do. 13W plus 23W minus 7W plus 7. Let's say I put parentheses around those ones. We're going to talk about 3 different things you can do with equations. You can move the parentheses. You can move the terms. And we're going to do more of this another day, but I'll just kind of put it here. We can combine terms. We can combine the terms that are alike. We can combine like terms. So what do I mean by move the parentheses? What I mean is these parentheses around these two. There's a plus there, but I can put those two together. What this says is I can take the parentheses off of there. I'm still writing this in the same order. But I can put the parentheses around these two if I wanted to instead. That minus is still there. And you're thinking, well, why would we do that? Well, because PEMDAS says we do parentheses first. And let's say I didn't want to do something with those first. Let's say I wanted to do something with these first. Well, we can move parentheses around. It's called the associative property. And you can do that. You can move around which ones you add together first. You can move the terms. So on these ones right here, let's say I wanted to put the 23 first. The positive goes with it. And let's say I wanted to put the 7 next. So plus 7. This plus goes with it. Let's say I wanted to move the 13 next, and there's a positive number here. It's a positive 13, so I'll add 13. And then right here, this minus goes with the 7W, so I'm going to minus 7W. I can move around the terms. I can write them all in a different order. As long as I keep these operations with the right number, I can move those around as well. That's called the commutative property. You can move the parentheses, move the terms, and then and we'll do more of this tomorrow, but you can combine the terms that are the same. Let's see, there's nothing like the 7. The 7's, I can't do it, but I've got 23. Oh, and I've got 13 here. 23, I can put those two W's together. and I can add 23 plus 13. That means I've got 46 of them. Oh, but I've got this minus 7. I can even put those together. So I'm putting this together and this together and this together. So 46 minus 7, that's 39 W's. And then this 7, I can put the plus 7 afterwards. And that's called combining like terms. And today's assignment is a whole lot of moving around parentheses or moving around the terms and showing that it's still the same number. And then there'll be 1 or 2 about combining like terms. We'll do more of that tomorrow. We'll talk more about this idea tomorrow or another day, depending on when this video is being shown. But the main item today is just knowing that equal expressions can be made. If I have 6m minus 3j plus 4 plus 18j minus 64m plus 18. I can move these all around, and I'm going to move them all around. I'm going to put all the j's. I'm going to put this minus 3j, and that minus still stays in front of it. Just call it a negative. And then the 18j, I'm going to put that plus 18. Now I've got the j's together. I've got some m's here, so I've got a plus 6m. It's positive. I've got a minus 64m there. And then I've got plus 4 and plus 18, so that's plus 22. I've now moved around all these terms. I've kept the operation that goes with it so that it stays with it. I've moved them all around. And then I can add them. Let's see, I can put those together. I can move parentheses and do those ones first if I wanted. That's a minus 58m. And then I can combine those terms. Oh, whoops, that's a j. 15j minus 58m plus 22. These are just a couple examples to show you that you can move around terms. You can move around parentheses or put parentheses in a different place than they were. The parentheses would have been right here if I wouldn't have written them in. And you can combine the like terms. Just a couple things on equivalent fractions. You'll see more examples. You'll see more examples on the assignment. Give them a shot. See if they make sense. In class, we spend all class period doing these examples together. Use the helps that you have on the assignment, all the helps I've shown you throughout the year. If you need extra help, let me know. Thanks for watching. I hope these equivalent expressions don't give you too much grief. Thank you.